We'll now discuss rationalizing denominators. So the first question is, what do we mean by rationalizing a denominator? And the idea here is we don't want the denominator to contain radicals. When we've got rid of all of the radicals, all of these roots on the denominator of the fraction, we call it rationalized. So we're going to do this by multiplying by something to get rid of the radicals. So we're first going to start with looking at what we can multiply by to get rid of these radicals. So here are a couple of examples. First, we just have the square root of 7. And whenever you have just a normal square root of a number, we can just multiply by itself, because the square root of 7 times the square root of 7 is the square root of 49, which is 7. Whenever we have an addition or a subtraction situation, we're going to multiply by the exact same thing, only changing the sign in the middle. So this was the square root of 7 minus 1. I'm going to multiply by the square root of 7 plus 1. Since the only difference is the sign, whenever we multiply these out, we can just square the first one minus square the last one. So this would actually give us 6. A few more. This one, we would once again just want to change the sign in the middle. It was a plus, so I'm going to make it a minus. So when I multiply, the square root of 5 squared is 5, and the square root of 2 squared is 4. So this one would leave us with 1. The second one, the fact that there's 2 radicals doesn't change anything. As long as there's 2 terms, we're just going to change the sign in the middle. The square root of 5 squared is 5. The square root of 7 squared is 7. And so this would be -2. If we're dealing with higher roots, it might be a little bit trickier. If we follow the pattern we've been doing, we would just multiply the cube root of 3, which would give us the cube root of 9. So that can't be it. Instead, we're going to multiply something that gets us to where we want. We only have 1 3 here. However, since this is a cube root, we need 3 of them. So I need to add in 2 more. So I'm going to multiply by the cube root of 9 to get the cube root of 27, which is 3. We'll now look at actually rationalizing these. So we talked about with the square root of 7, we want to multiply by the square root of 7. And we can't just multiply the bottom because that would change the problem. Instead, we have to multiply by 1, since multiplying by 1 doesn't change anything. So on the top, 1 times the square root of 7 is the square root of 7, and on the bottom, we get 7, since the square root of 7 times the square root of 7 is 7. Another example, to get rid of the root, we would need to multiply by itself, so the square root of 5 on the top and the bottom. On the top, I have a 2 square root of 5. On the bottom, I have a 3, and then the square root of 5 times the square root of 5 is 5. So this is 2 root 5 over 15. The next one, here we would want to just change the sign in the middle. So the square root of 3 minus the square root of 2. And when we multiply this, we need to make sure we multiply out across. So the square root of 3 times the square root of 3 is 3. And then the square root of 3 times negative square root of 2 would be negative square root of 3 times 2. On the bottom, square root of 3 squared is 3, and the square root of 2 squared is 2. So the denominator is just 1. So we get 3 minus the square root of 6. Our last example here, I would need to change the sign on the bottom to a plus and then multiply by that. On the top, we're going to want to FOIL this. So the first term's the square root of 5 times the square root of 3 gives me the square root of 15. The outside terms, the square root of 5 times 2 times the square root of 5. Well, the square root of 5 times the square root of 5 is 5, plus we have this extra 2. That would make it 10. The inside terms, 1 times the square root of 3 is the square root of 3, and then the last 2 terms, 1 times the square root of, or 1 times 2 square root of 5 is just 2 square root of 5. On the denominator, I square the first term minus squaring the last term. The 2 squared is 4, and the square root of 5 squared is 5, so that would give us a 20. So I end up with square root of 15 plus 10 plus the square root of 3 plus 2 square root of 5 all over negative 11. And you'll notice on the top we cannot simplify anything. The only way we can add roots is if what's inside of the square root or the cube root is the same, and it's not for any of these.